Assalamualaikum and good morning. Today we will learn about new topic alkene. In this video we are going to study structure of alkene, nomenclature of alkene and also preparation of alkene. Alkene, also known as olefin, is unsaturated hydrocarbon containing at least one carbon-carbon double bond. The general formula of alkene is CnH2n. Nomenclature of alkenes apply the same basic principles with nomenclature of alkenes. Step 1. You have to find the longest carbon chain containing carbon-carbon double bond. Let's look at the two examples given in the slide. The second one is wrong because it does not contain any carbon-carbon double bond. Step 2. Number the carbon atoms at the end nearer to the carbon-carbon double bond. Carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5 and carbon number 6. If carbon-carbon double bond is at same distance from the two ends, begin at the end nearer to the first point of branching. Since the branching is near to the left end, so you have to number the carbon starting from the left to the right. Make sure carbon-carbon double bond get the lowest possible number. Step 3. Once you have located the position of the substituent, write the full name of the compound. Use prefixes di, tri, etc. if you have same substituent present more than once. If you have more than one substituent present, identify the location of the substituent and list them alphabetically. For example, 3-isopropyl 2,5-dimethyl 1-hexene. To name cycloalkenes, the numbering begins at carbon atom bearing carbon-carbon double bond as carbon number 1 and carbon number 2. The first substituent has to be given the lowest number possible. Which structure do you think have the correct name? The answer goes to the first one on the left, 1,5-dimethyl cyclohexene. This is because the first carbon of the double bond has one methyl substituent attached to it, whereas the first carbon on the right-hand side of the cycloalkene shows no substituent attached to it. Let's name this compound together. First, identify the presence of the functional group. The functional group present is carbon-carbon double bond. Therefore, you have to number the carbon beginning from the right-hand side at the end near to the functional group. Second, identify the location of the substituent. It seems that the substituent present at carbon number 3. Next, you have to name the compound, which is 3-cyclopropyl propene. Cis trans isomers, also known as geometrical isomers. Cis and trans isomers are possible only if an alkene has two different atoms or group of atoms attached to it. For example, 2-butene. Each unsaturated carbon has one hydrogen atom and one methyl group attached to it. Two groups present on the same side is known as cis isomer, while if the two groups present on opposite side known as trans isomers. These are the two characteristics of cis and trans isomers. The third subtopic that we are going to cover today is preparation of alkene. Alkene can be prepared by elimination type reactions. The name of the reaction is dehydration of alcohol, which means loss of water from alcohol. In dehydration of alcohols, hydrogen and OH are removed from adjacent carbon. In this reaction, sulfuric acid acts as an acid catalyst. Sulfuric acid and also phosphorus acid are the most frequently acid used in the dehydration of alcohol. It can also be substituted by potassium hydrogen sulfate. Setzaff rule. Setzaff rule states that in elimination reaction, the most stable alkene is the alkene which has a greater number of alkyl group attached to the carbon-carbon double bond. Here we have 5 alkene structures. The one on the right hand side have 4 alkyl group, meaning that it has the highest stability compared to the structure on the left hand side, which is ethene. As shown in the slide, OH group is attached to carbon number 2 in 2-butanol, meaning that you have to remove OH group from carbon number 2 and one hydrogen group from either carbon number 1 or carbon number 3. If you remove hydrogen from carbon number 1, you get 1 butene as a product. While if you remove hydrogen from carbon number 3, you will get 2 butene as a major product. The same principle applies for 2,3-dimethyl 2-butanol. By removing the more stable hydrogen, you will get major product. And remove the less stable hydrogen, you will get minor product.